Thank you very much. So first off, I was told that this was a deep dive conference, but then I found out that I'm given a lightning talk slot. So we're not going to go through all of this presentation, but the presentation is available here, and the full presentation there's already a draft version of the full presentation on YouTube, and I will probably do another full version of the presentation later. Also, if you want to connect with me, boom, there's how you do it. Whoever gave that last talk should connect with me because I know somebody that might want to be your business partner. Dangerous wrong thinker, equal opportunity offender, technophobic, extraordinaire. That's my updated bio. That one was old. I stopped trying to bring back the magic of 2012. My latest hobby is riding four-wheelers, so that's about me. Today I'm representing Savvy.legal. We're a business lifecycle platform. Basically, if you are getting ready for investment or any sort of thing where you need a data room or got to work with lawyers, you want our platform. And we are looking for a really good front-end developer. I also work for Dash Incubator. That's kind of a side hustle, which is a digital cash platform. And we're also looking for really good developers as well. So without further ado, JS with types, types without transpilation. And basically the number one thing you need to know is what I've got here on the screen. If you don't walk away with anything else, npx, JS what, init. And there's useful links here at the beginning of the slide and reference material here at the beginning of the slide so you don't have to go through the whole thing. Now this is not a gateway drug to TypeScript. So hopefully you're here because you didn't want a gateway drug to TypeScript. Instead, we're going to code like it's 1999, except I'm really just trying to convince you that Go and Zig are the languages that you ought to be using, and JavaScript is a good way to get there, kind of, sort of. So let's start out with zero is philosophy. Why are we here today? Hopefully we believe the same things. Why JavaScript types? Well, because build steps are not good, and slow build steps are evil. And code gen is way better than metaprogramming. Duck typing is good. Inheritance is evil. Better tools make for better developers. Copy and paste and find and replace are not bad. Transpilation is evil. I think I said that one twice. So kind of these are the philosophies. If you go to creedsofcraftsmanship.com, these are kind of philosophies that I draw from why I landed at JS with types rather than say TypeScript, because I want something simple. All right, so now on to number one. Types are and always have been, since the very beginning, in the tooling. So JavaScript has always had types, quack, quack. It's just duck typed. In fact, it's got a lot of types. So we're going to talk about all of this, except we won't actually get through all of it. But you've got your primitive types, those you mostly know about, your Boolean, number, string. You might not know about big int. You might not know about int and uint. But those are primitive types that JavaScript has. We've got function. You know about that, of course. Probably not as much as you should, though. And then we've got kind of this nullish thing going on, which is aside from types, because we got null and undefined and not defined. And we don't have time to go into the differences between those three, but they are actually different. Then you've got, so these are your primitive single value types. Then we've got your multi-value types, your struct. That's your curly brackets. Sometimes people mistakenly call it object, as in every time. You've got your tuple, which is square brackets, which is just like a struct. We will cover that ever so slightly. And then you got some weird things that have come in, weak map, weak set, some other stuff. Apparently there's a tuple type that's coming in, but we already have tuples. Then you've got your collection, your collection types. So a map is a key value pair. So, well, yeah. And then a list is index values. And collection types are things that are similar that go together. And then we've got the meta types. And this is the stuff that you only get from tooling in JavaScript. JavaScript, and no language does anything with any of these things. All of that stuff is in the tooling. When the program runs, it doesn't know about any of that stuff usually, except for interfaces. So because in JavaScript we have bad tools, JavaScript has a reputation for having bad types. But we're here today to fix that. I'm going to hopefully help you to understand how you can use some of the tools that are out there to use type with JavaScript. So, and actually, let me make sure I refresh this. Okay, so we get this. String, message string, answer 42. We got a string, we got a number. If you use JSDoc, then you can say, the type of this thing, I expect it to be a string. Not just it is a string, because it always had a type, but I expect it to be this type. And likewise, I expect it to be a number for the answer here. So the purpose of JSDoc is to help us communicate our intent, because the has-been native tooling of JavaScript has not helped us to do that. But with JSDoc, we can communicate our intent. And if you want to use JSDoc, all you need to do is npm install location global JSDoc, and you have JSDoc. So you can use JSDoc comments whether or not you actually have JSDoc installed, but if you use JSDoc, then you can actually get the documentation for your code auto-generated for you, and that's kind of nice. And then we have TSC. Now TSC, what it lets us do is take it one step further. JSDoc allows us to get the documentation to communicate the intent. TSC will actually give us errors in VS Code or Vim or wherever it happens to be that you like to dev in. The purpose of TSC is to catch, correct, and classify type errors. And do not be alarmed. Yes, you need to install TypeScript, but no, we will not go over any TypeScript today. No TypeScript. It just happens to be that TSC is the TypeScript checker. That's what it stands for. So the next thing that you need to know, now you know what tools you can work with to help you do some stuff. Next thing you need to know is how to configure it. Well, it's pretty simple. You know, you just pass these 17 options, and then you edit some config files, and you Stack Overflow, and so in preparation for this talk, because again, I don't have 3 hours to explain to you how to do the config, what I did was I created a tool, JSWhat. So JavaScript with types. And so now, all you need to do is run your npm init, and then npx JSWhat init, and then occasionally npx JSWhat reexport. And we'll talk about why reexport in a bit. But basically, now, you have an easy way to get your jsconfig.json that will work with the TypeScript checker, that will work with vanilla JavaScript. And there are blogs and stuff on how to do this, but before, like I said, it takes a long time to explain it, and a lot of reading and trial and error. All of that is taken away now. So rejoice. So JSWhat stands for JSWhat types. You can pronounce it JSWhat. And this is basically what you get. So I'm going to go over this a little bit because it's important. There's a prettier ignore, just because assuming you're using prettier, and there's some things that need to be ignored. For example, you don't want prettier to run over your documentation that gets built. You've got a docs folder that comes from JSDoc. You're going to have index.js, but you don't actually use that. That just goes into lib foo.js or whatever the package name is, because of the way this works, your types actually have to go into index.js if you're publishing a module, which we may get to talk a little bit about more later. But all this stuff is done for you. It's set up correctly. There's comments inside. You got your jsconfig.json. VS Code already knows what to do with that. If you have ale for Vim, it already knows what to do with that. So you don't have to do any special configuration in your editor. Then you've got your jsdoc.conf.json, which has some details about how to generate the documentation. Your package.json gets updated with npm run lint that will run the TypeScript checker, and npm run doc that will generate your documentation for you. And then you'll have a types.js and a typings folder, which unfortunately we won't have enough time to talk about that last one there. But you'll get a couple of commands: npm run fumped, npm run lint, npm run reexport, and I think there was one other one that, oh, npm run doc should have been on here as well. So those are the tools that you get to use. Now, let's talk about how these tools actually get used. I want to get that out of the way because it was really hard, and now it's not so hard. So JavaDoc and C# had a baby once upon a time, and this is what the syntax looks like when you're using these typing tools. So notice there's a double asterisk. All type annotations must start with /double asterisk. You cannot use inline comments. They must be block comments, although you can inline comments like this. but any comments related to JSDoc or the TypeScript checker must have the double star. That's super important. And so an inline type, we you already saw this before. You just put @type, and then you give it a type name. So string, number, Boolean, etc. You can also do inline parameters. So if you have a variable, you just put @type over top of the variable. You can also cast variables this way, kind of, sort of. You can have inline parameters for a function. So we've got a function greet, and it takes 2 parameters. One parameter is a string, what the greeting is, and you'll notice the square brackets there. That means it's optional. So that's how you denote that you don't have to pass that in. It could be not defined or undefined, which is different from null. You see 3 params, but there's only 2 parameters that go in. And the way that the inline parameters work is if you don't want to create a definition for a specific type, if this is just kind of a one-off function, then you can say @param object, give the object a name, and then @param, and then define some sort of nested property within that object. And you could do that 100 million times. Now, struct definitions are similar to what we just saw, but we would use @prop. We use @typedef, not prop. So first line is what you want to show up in the documentation for the short description of the type. Then you have @typedef in the type name, person in this case, and then you add your properties. And so we can have age as a number, and then the comment. So the comment for the type goes up top. The comment for the properties goes to the right after a hyphen. So this is the syntax for that. And then, yeah, I think that's it. Oh, and we've got a function there as well. So we've got a number, we've got an array, and then functions, you pretty much always need to create a type for the function because functions take different parameters that have types and such and such. Okay, so if we're looking at a function definition, interestingly, you have to use the @function. Or I mean, sorry, whoop, I totally goofoed it. You have to use @callback. You would think you use @function because if you look at the documentation, there is an @function. Don't use it because it works half the time. There's a bug open in the TypeScript checker about it, but they just don't care because @callback works. So their solution is, well, just don't worry about it. Use @callback. So function definition is almost the same, except that instead of @prop, we have @param, and then you can also have @returns and @throws. And then if you have an async function, you promise angle brackets string. So this is what a function definition looks like. And I don't know why there's 2 of those. Something went wrong there. But like I said, you just know that you cannot use any other way of declaring a function because there's at least 3 ways of declaring a function in JSDoc. Only the @callback works. There's the bug if you want to go bug Microsoft about it. And then an important distinction, I get hung up on this all the time. I lose 20 minutes just trying to figure out what the heck was going wrong. There is @param and @prop. @param is for parameters that are received by a function. @prop is for properties of an object. Now remember, a function is an object. So a function can have both parameters and properties. So I'm not recommending that you do this. I don't think this is generally a good pattern. Certainly documenting code that exists, you would have to do this. jQuery was this way, for example. But so if we had a function that's greeter, then we could have a param that it receives that's person other, and then we could also attach to that function a property foo that has bar on it. So there we go. Now, nullish definitions, there's a couple of ways to do it. When you are typing something, you can actually include the nullishness as part of the type when you create the type def. But for simplicity's sake, if we want to do @type Boolean, alive, and this cat, maybe it's dead, maybe it's alive, Schrodinger's cat here. So we can have it be set to alive, to true, false, or null. And that question mark is what does that. Now, if we also wanted to let it be undefined as well, which in this particular case, undefined and not defined fall into the same category, then you could do a pipe and undefined. And this would mean that the cat can be alive or dead or null or undefined. I mean, it could be aliveness of the cat could be true or false or whatever. Anyway, you get what I'm saying. So then we have our map types. Map types are object dot and then a key type and a value type. So for example, you could have a string type that's named, the key type always must be a string, but you can narrow what a string means, or you can have a marker type, which we'll talk about that a little bit later. But yeah, so we might have the object may be typed key string, value string, or key name, which is a string and value number. But what you can't do is you cannot have anything other than a string as the key type, because that's how JavaScript works. Anytime that you use the object syntax in JavaScript, you are going to, the key will be converted to a string no matter what. And then I would recommend against doing this. You could say any. You could say, well, the key could be a string of some sort of type, and then the value could be any. It could be a number, it could be a string, it could be a blah, blah, blah. But I question why you would need to do this. Then we also have tuple types. So tuple types, square brackets, and then you have whatever the types are that are in that tuple. So tuple, unlike a list, a tuple is a defined set of this many things together. I'll skip over that for now. And then you can do a type extension. So you can use an ampersand any number of times to extend a type. So you could have a person base type, and then a person extra type, and so on and so forth. And you could say, if we combine all these together, that's a full person. Or a canonical example, file, folder, symlink, pipe are all dir entries. That one's not an and, that's an or, by the way. I skipped over that a little quickly. So a dir entry is a file or a folder or a symlink or a pipe. You can have a narrowing function which does the opposite. So if you have a dir entry and you need to say, well, I tested this, I know that it's a folder, I need it to be treated as a folder, I don't want to get errors about me accessing a property that exists on a folder that doesn't exist on a file. What you do is you create a narrowing function that returns the value as a type, so, or is. This value is this type. So that's a narrowing function. And then you have some utility types too. So one of them is partial. Another one is required. So partial just says, well, take a person, but make it person-like. A person-like object is like a person, but all of the properties are optional. So name is optional, so security number is optional. I'm just going to pass something in, and it's person-like. Don't check too strictly that what gets passed in must have every property. And then required is kind of the opposite. It takes something and says make everything non-optional. I don't remember what I was going to say about this, so I'm skipping it. Though there's lots of little quirks, and that's the problem with JavaScript with types, is that you can use the tools, but the tools, JSDoc was built for Java, and TypeScript was built for C#, and so we have a lot of just little quirky things, but if you use the small subset, you can get along pretty well and be happy. We also have utility functions. So for example, if I wanted to get the last element of an array, what type the array is doesn't matter, that's completely transparent to me. And you might think, well, I could just say this array is of type any because I don't care, but the problem is then what it would return would be an any, and then you'd lose the type information about the object. So instead, with a utility function, you can use this thing called template, and you can say that the template is of type any, of type T, and what I receive is array of type T, and what I return is type T. And what this does is say, well, you can pass anything in, and whatever you pass in is what gets returned back. So your linter won't complain when, because otherwise you pass in a person and it comes back out in any, and you try to access some property on it and says, this is an any. We don't know what properties it has. And then you have utility-ish functions, meaning that they're utility functions, but they're scoped to a specific category of types. So for example, I could scope my type to anything that's person-like. So I don't care what the type is, but it has to be person-like. It has to have some properties that a person has. And then we're going to come back around and then return, if they passed in a full person, if they passed in a base person, if they passed in a person with friends, whatever type they passed in, that's what type they get back. So the way that you import types is if you need to use types from other projects, if they're not automatically detected, then sometimes because a lot of times they will just be automatically detected, but if they're not, then you might try doing @types and then whatever the name of that project is, and you can install that, and then you'll get the types for that project. So for example, here's how we do that with Express We could type a function, import express handler. And then there's re-exporting types. So if you were going to publish something to NPM and you want its types to be available, this is what I was talking about earlier. The index.js file is reserved for having all of your types imported from everywhere in your project and then re-exporting them in the index. So when somebody else requires it and imports it, all of your types are available at the top level and they don't have to dig down 5 files deep to figure out what type something belonged to. So this is how you re-export a type. You just type def, do the import just like you would with a type, and then give it a name. All right, now, congratulations. That is 100% of everything that you ever need to know to represent any type that can be represented in JavaScript with JSDoc and TSC. So give yourselves a nice round of applause. And if you want to see the resources for those in particular, there they are. Now, I was going to do a bit more of a deep dive and talk more specifically about the types of types, but we don't have time. I wanted to leave some time for Q&A, that is. So I'm just going to flash through a couple of these. We kind of talked about the difference between structs and maps. A struct is basically, oh, I had a good explanation here. Struct is like Mr. Potato Head. It's a kit of stuff that belongs together, as opposed to a map. It's just a normal, plain old JavaScript object, is what a struct is, as opposed to a map, which is like, I don't know what that first thing was supposed to be, but that obviously got pasted wrong. But a map is a collection of like-ish things. So, you know, if we had a bunch of people and we wanted to index them by a name rather than by a number, that's a map. We get tuples are kind of like a kit by numbers. A tuple is when you have a structured set of things, but they, yeah, it's based on the order rather than being based on the name. That's what makes the difference between a tuple and struct. In memory, they're the same. When it gets past the tooling and into the optimizer, they're the same thing. So list you're familiar with. That's what we typically call arrays, although JavaScript doesn't actually have arrays. And then enums are really cool. We have these in other languages like Rust, but essentially this is what a value enum looks like. You can take some values and OR them together and give them a type. And then we have value enum, or type enums, which you can take things that are of similar types and OR them together. So the thing that you want to do with type enums is you want to make sure that the types are some way similar. They're array-like, or they're, you could give them some sort of likeness. What you don't want to do with type enums is to go, oh, well, I'm going to convert this thing into a big num or a big int, therefore I'll accept string or number or big int. This is kind of a code smell. Have a separate function, one that takes in the big int, one that takes in the number, one that takes in the string, do the conversion in there, have that pass through. Don't muddy up your types. But with that said, we kind of covered the most important stuff. So let's come back up for air. And do we have any questions? There's 1 minute on the clock. Yes, sir.
So where do the type errors actually show up? Is it like if you're using VS Code, this type of setup?
The type errors show just the way they normally do with linter errors. So you'll have the little squiggly in VS Code or the underline in Vim, and then in your error message bit at the bottom, it'll tell you what the error message is. And if you run npm run lint, then it will give you the big long printout with all the things across the project. Yes, sir?
Why is this better than TypeScript?
Why is this better than TypeScript? Refer back to the philosophy. If you like TypeScript, it's not better than TypeScript. All right. Well, that's all we got. For those joining in online or here, like, sub, follow if you want to. Thank you.